Hello and welcome to Geometry Unit 5, Properties and Attributes of Triangles. Today's lesson will be on skill number 26. I can prove and apply theorems about angled bisectors and perpendicular bisectors. Our skills for the unit will be found on page 05-01. And moving to page 05-02, we can see that the skill number 26 starts on that page, angle bisectors and perpendicular theorems. I have created on this page two trifolds for you, and off to the right is the first trifold. So perpendicular bisector theorem. Up here we have some vocab words for you. When a point is the same distance from two or more objects, the point is said to be equidistant or equidistant. A line that is both perpendicular to a segment and bisecting the segment is called a perpendicular bisector. So that goes on the top inside flap, and then on the exposed flap when you open it, I have this drawing, which is a drawing of the perpendicular bisector theorem. The perpendicular bisector theorem says that if we have a line xy that is perpendicular to the segment AB and it bisects the segment AB, then a point on that line is equal distance from the point to x and the point to B. Perpendicular bisector theorem. On the inside of the perpendicular bisector theorem we have what it says in words rather than diagram form. The converse of the perpendicular bisector theorem then would be stating the converse. So if you have a point on the line that is equidistant to A and B, then we know that that line is perpendicular and bisects. That's on the top of the first flap, and then on the very inside of the trifold is the converse of the perpendicular bisector theorem in words. So those two are the perpendicular bisectors, and now let's talk about the angle bisectors. We have two angle bisector theorems, the angle bisector theorem and the converse of the angle bisector theorem. Over here to the right we have the inside flap of the angle bisector theorem, and then we have what the theorem states in words on the very inside. What it's saying is if you are given an angle that is bisected, then the point on the bisector, the point on PC, is going to be equidistant to the two rays. Erase that up for you. And then finally the converse states, of course, the converse of that, and that is if a point is located on a ray inside the angle and it is equidistant to the sides of the angle, then we know that the ray bisects the angle, or consequently those two halves are congruent to one another. Alright, next I'll show you a couple examples of how we use these theorems. Example 1, we are given a diagram and they tell us that angle APB is 6x minus 8 degrees. And we're also told that angle BPC is 5x minus 6 degrees. When we look at the diagram, we see that B is actually equal distance to A as it is to C. B is the same distance here and here. So by the converse of the angle bisector theorem, we can conclude that these two angles are congruent. This knowledge allows us to set 6x minus 8 equal to 5x minus 6. From there we can go about solving and finding out what x is. So because the two are equal, we find that x is equal to 2, and then we can figure out what each angle is equal to. So that 6x minus 8 could be 12 minus 8 or 4 degrees. And since they're congruent, the other one is also 4 degrees, which means the total angle is 8 degrees. When we're given a problem like this, sometimes we're finding the measure of one angle, sometimes we're finding the measure of both angles or the total angle, and sometimes even we're going to be finding the length of the distance. So the example shown is just one possible way we can use the angle bisector theorem. There's a few different ways we can use the perpendicular bisector theorem, but first, before we get into that, let's recall a few important things. The midpoint formula is listed here. Usually I say in class, take the average of the x coordinates and the average of the y coordinates, and that gives you the midpoint. The point slope form of a line is listed y minus y1 equals m times x minus x1. And then lastly, if you want to find the perpendicular slope, take your slope and find the negative reciprocal. So if your slope is 7, you have a perpendicular slope of negative 1/7. If you have a slope of 2/3, perpendicular slope of negative 3/2. Negative reciprocal. Now, if we had a slope of negative 5/4, then the perpendicular slope would be 4/5. So it's all right. And on to the next example. There's a question quite similar to this on the skill test and the post test for the unit. Example 2. Write an equation in point slope form for the perpendicular bisector of segment AB, given that A is at 5, negative 4 and B is at negative 11, 8. I've listed out a 4-step process for doing this. Step 1, find the midpoint. Step 2, find the slope. Step 3, find the perpendicular slope. And then step 4, we use those two in point slope form to generate our answer. So, first things. First, we find the midpoint. We take an average of the x coordinates, that gives us negative 3, and an average of the y coordinates gives us 2. So we have point negative 3, 2. Next, we need to find the slope AB, the slope of a line segment AB. And we have our slope formula here. y2 minus y1 divided by x2 minus x1, or rise over run. And I've worked that out. And as we reduce it, we get a slope of negative 3/4. If our slope is negative 3/4, then we know that the perpendicular slope is the reciprocal negated. So negative 3/4 becomes positive 3/4, and then we reciprocal it, or take the reciprocal of it, and we get 4/3. So we know that our perpendicular slope is 4/3. And in step 4, we take those two pieces of information and plug it into the point slope. Plug it into the point slope equation. So the -3 goes in for x1. The -2, let's do it in a different, -2 goes in for y1, sorry, +2. And the slope goes in right there. All right, that concludes the lesson notes on skill number 26. On the skill test for number 26, geometry, we will need to be able to apply the perpendicular bisector theorem, and the angle bisector theorem. So there will be diagrams that will relate to those, and then also we should be able to find the equation of a perpendicular bisector given 2 points. Just like the final example we worked through. All right, thank you.